a couple of different things. The first one is all these translations of graphs. So the theme is new functions from old functions. So the first thing we're going to talk about is like translations and also shrinking and stretching and this kind of stuff. And then later we'll get into adding and subtracting functions, and then composition. We'll finish it off with composition of functions. Okay. Okay. So the first part. So essentially, the situation is you have a function y equals f of x, and that gives you some graph of some function. Okay, so if you have this other function here, which is related to the original function f, but it's f of x minus h plus k, then this k is going to shift the graph up by k, and this h right here is going to shift to the right by h. Okay, so this k, it's a plus k, it's up by k, or if k is negative, then it'll go down. Here, if h is negative, then it will go to the left. Okay, but there's this negative sign here that's kind of built in. Okay, that's confusing. Okay, in this situation right here, the a will basically stretch vertically. Okay, so the a is a vertical stretch. If it's negative, then it's going to flip it through the x-axis. Okay, so it's going to be a vertical flip through the x-axis. And this b right here, this will actually shrink it by a factor of b. So if b is like say 2, then the graph will be, and the shrinking will be horizontally. Okay, so for example, if b is 2, then it's going to shrink the graph horizontally by a factor of 2. It's going to just, everything is going to, so any point, all the points on the graph will be moved half the distance to the y-axis. Okay, this one, the a outside. If a were 2, then the distance between each point and the x-axis would be doubled. Okay, if a were 1/2, then it would be cut in half. If b were 1/2, then it would actually stretch it by a factor of by doubling. Okay, so that's how that works. Now, in general, the way that I think about this is if it's outside, like for example, the k and the a, those are outside these parentheses here, then they're vertical and they're in the natural direction. So if this is a plus, if k is positive, then it's going to shift it up. K is negative is down. Okay, if a is positive, is greater than 1, then it's going to be stretch it. If a is between 0 and 1, then it's going to shrink it. And they're in the vertical direction. Okay, and the inside stuff, like the h and the b, their effect is horizontal, and it's kind of in the opposite direction. Okay, so b shrinks it instead of and so on. Okay, so let's go to Webassign for a second, for a few minutes. If I can. And if you're able to, that's probably a good idea for if you all go to Webassign and as we're doing class, then you can get the homework done, and then it's maybe more of an incentive. Hopefully, it's more of an incentive to follow along with what's going on. Okay, so number 1, suppose the graph of f is given. Write an equation for each graph described that is obtained from the graph of f. Okay, so shifting it 3 units upward So which one would that be?
It would be f of x plus 3, right?
Yes, it's this one right here. Because it's outside, and so upward means it's a vertical and it's going up, so it's a plus 3. Okay, downward would be the minus 3. Okay, and then 3 to the right would be which one?
Be the second to last.
Yes. Okay, so the minus means that the minus means it's going to go to the right, so kind of the opposite direction of what you. So minus, you'd think, oh, that's to the left, but it's to the right. And then to the left would be the plus 3, this one here. And then if you want to just reflect it, well, no, and there's lots of these. Okay, if you want to just reflect it through the x-axis, okay, that is vertical, so that's going to be outside, and that will be just this right here, a minus, putting a minus on right there. And if you want to reflect through the y-axis, that is a horizontal reflection, so you put the minus inside the parentheses. Okay, G, stretch vertically by a factor of 3. Which one is that one going to be?
That's going to be the last one, y equals 3f of x.
Yes, and then shrinking vertically by a factor of 3, that would be that one. Because vertical is outside. Okay, so let's see if we got those correctly. If we got those correct. Submit. Boy, they're really obsessed with the number 3 on this problem. And the obsession with 3 continues with number 2. Look at that. Okay. So now we have f of x plus 3. The plus 3 is outside, so that's going to move it up by 3. This plus 3 is inside, so that's going to move it to the left. Okay, because it's plus. So this is the opposite direction of what you expect, because it's inside, and so inside means opposite and horizontal. Okay, what about this one? 3f of x. Excuse me.
That would shift the graph vertically by a factor of 3.
Yes, it stretches it vertically by a factor of 3. And this one, part G. So that's inside. Inside means horizontal and opposite. So this would be shrinking it horizontally by a factor of 3. Okay, oh no, part E. There's like lots of stuff going on right here. Okay, so you start with the inside and you work your way out, and this is what gets applied first. So first, it's going to be a reflection through the x-axis, because this is outside, so that's vertical. And then you're going to shift it down by 2. Down by 1, I mean. So first to the x-axis and then shift it 1 downward. Okay, here, let's see, 1/3. So you apply this first. So it's going to stretch it horizontally by 3. And then this is stretching by 3 also. Okay, let's see what happens with that. Let me get all those ends right. Okay, great. So that's those exercises. Okay, so let's go to number 3. And what we have here is, this is the original graph. And then if we apply, and down here, we're supposed to figure out what's the graph of y equals f of 2x. Okay. So what does the 2 here do? I'm supposed to be pointing at the 2. So it's inside, so that means it's horizontal and it's opposite, so it's going to shrink it horizontally by a factor of 2. Okay, so that means that this point right here is going to go, what is it, 2, 4, 6, 8, 10, 12. So that's going to go to, this point right here is going to move over to here. This point is going to move over to like right here. Okay, so you look for a graph where that's the case, and it looks like this one right here. Okay, this has been moved over to there, and then this moves over to here. Okay, so that one went to here. Okay. So let's go to the next one. And here, what's going on here? Anybody want to tell me what this does?
Wouldn't it shift it horizontally by a factor of 2? Increase it as opposed to decreasing?
Yes. So stretch horizontally by a factor of 2. So this point right here gets doubled out to here. So like this point is doubled. So here they just like made the graph smaller, but that's basically the same thing. So this looks like the one right here. Okay, let's try the next one. So does anybody remember what this one does? The minus sign right there. The minus inside. I mean, I probably wasn't that clear about what putting a minus would do, but I think I did mention it once. Does anybody remember?
Doesn't it go on the other side?
Yes, it reflects it. Reflect it.
Yeah.
It's horizontal reflection. So this point right here this point's going to go over to the other side. It looks like maybe that one. I think this is the only one that does it. So this one will stay where it is. Okay. And this one would go over to here. Okay, so that one goes over to there. So this looks like the answer right here. Okay, the next one. Whoa. Now this one, it has this and that. So this is going to be horizontal and vertical reflections. So that means that, like, if we take this point right here, it's going to get flipped over to here. This is going to go over to there somewhere, and the other side. Oh, but then it doesn't flip through the. But then it doesn't get reflected because it's already on the x-axis. So things that are on the x-axis are immune to vertical reflections. Wow. But let's say this point right here, that one's going to go over to here, and then the horizontal reflection inside. And then right here, it's got the vertical reflection. So from there, it's going to go down to there. Okay, so that point ends up going over to here. Okay, so let's see if we can see let's go where a graph like that. It looks like maybe this one right here, and then this other one's over here. So this one got flipped over, moved over to there. So I'm guessing that's the answer. Let me check. Yeah, that looks good. Okay, number 4. So it says graph this function up here, not by hand, okay, not by plotting points, but by starting with the graph of one of the standard functions and then applying the appropriate transformations. Okay, so let me just show you how this is like really confusing probably as to what they want you to do, but let me go, but basically they want you to use transformations and stuff to do it. Okay, so you know that, so the idea is, the first thing is that you know that this graph right here, y equals x squared, that just looks like this. It's just a parabola like that, okay? So that's that graph at the origin. And what they're saying is this is actually just a couple of transformations, a horizontal and a vertical transformation, take from here to here. So what you're going to do is you're going to you take this guy right here, and you're going to complete the square, okay? And what that means is that we have this x squared minus 4x. We're going to add something there that makes all of this a perfect square. But just so we don't get in trouble, we have to subtract whatever we add here. We have to subtract here, okay? And then this new form right here will still be the same as that one. They'll still be the same. Okay, so what you do is you take this number right here, so -4, and you divide it by 2, and that gives you -2. Okay, and then you take that -2 and you square it, and that gives you 4, and that's what you're going to add and subtract. Because if you do that, then, and you probably, I'm sure everyone has seen that done before, but what happens is you get this, because all this becomes just x minus 2 squared. And you can verify that by just multiplying those out, and you're going to get this, okay? Use the flow method or whatever. And then over here, this is a 4. Okay, so then the question is, so you look at this and you say, if I'm going to go from here to here, what does the 4 do? And what does the -2 do? The 4 means what?
It's going to shift us 4 vertically.
Yes, up 4. So 4 vertically. And the 2 means is to 2 to the right. Okay, so you're going to take this graph right here. It's going to go up 4 and 2 to the right, and so it's going to be right here, and then that's going to be the new graph. So you just look at which one of these does that, and it looks like this one right here. Yeah, so that's the answer to that one. So that's how you do that one. Okay, so So the 1 through 3, we kind of talked about functions in general and inside and outside or whatever. But here you can kind of see it in action. This is inside, okay, of this function here, f of x equals x squared, and this is the plus 4 is outside. Okay, so there'll be more problems like that. So we have sine of 1/4 x. Okay, so we know that the sine looks like this. It goes to 0, 0, and at pi it's back down to 0, but at pi over 2 it's kind of at its high point. It's up here at 1. Okay, and then between pi and 2 pi it goes like that. Dang, I have a little bit distorted here. So it's just like it's a wavy. It goes like that. Okay. Okay, so that's the sine. Here we have sine of 1/4 x though. So what does the 1/4 do?
It stretches it by a factor of 4.
Yes, so it's a horizontal stretch. Horizontal stretch by a factor of 4. Okay, so that means that in going from here to here, in doing this first hump right here, instead of going from 0 to pi, you're going to go from 0 to 4 pi. Okay, so that looks like a 4 pi right there. So it's going to be this third one's going to be the answer, because none of the rest of them do that. Okay, so the idea is, if you think about this some more, the idea is that if x is 4 pi, okay, so if we have f of x is sine of 1/4 x, then f of 4 pi is going to be sine of pi, whatever that was. So at 4 pi, you're actually getting what you're getting at pi. They're actually getting the value that you're supposed to get at pi. Okay, if you had like 2 pi, you're getting the value that you had at pi over 2. Okay, and so on. So that's why it's actually stretches instead of the other way around. Okay. So that was the first part about transformations and stretching and shrinking. So now we're going to get into some adding and subtracting and stuff with functions. And it essentially just works how you would think it would work. Okay, so that's the answer to the first one. So f plus g, just take whatever f is and add whatever g is, and there you got it. But it says, what's the domain? Okay, so maybe that in blue. So what's the state the domain of this new function? Okay, so so when it's asking about domains, again, like I said before, what you look for is avoid 0 in the denominator and avoid negatives under the square root sign. Okay, those are the two main things. So there's no denominator, so we don't have to worry about that. But what you want to do is you want to force whatever is inside these radicals to be greater than or equal to 0. Okay, so solving this one is pretty straightforward. I guess I could, a number of ways I could do this. I could subtract 5 from both sides, and then divide by -1. Okay, so I get x is less than or equal to 5 for that one. Okay, over here, I think that the most straightforward way to do it is like this. First, you factor this like that. Okay, then what you do is all these zeros here, so -2 and 2 are both zeros of this. They're both 0 there. And then you put the factors down right here. And this splits it up into 3 different zones. And you want to see whether these are positive or negative in each zone. So this first one, if it's x minus 2, if you're less than -2, that's negative here. And then right in here, okay, let's say for example 0, you can plug in any point in here and see what it is. If you plug in a 0, it gets negative. So it doesn't matter what the value is. What matters is whether it's positive or negative. And then over here, it's positive. Okay, for this one, it's negative, positive, positive. Okay, so in other words, every value, for every value of x that's over here that's less than -2, this expression here is going to be negative. But then if you're greater than -2, it's going to be positive. Okay, and this expression here changes sign right here. It's negative there, and it's negative here and here. But then past 2, it's positive. Okay, so now the reason that I do that is because we're interested in the product of these two, this times this. If you take 2 negative numbers and multiply them together, you take the product, which is what this is, which is what this is. This product is going to be over here. 2 negative numbers multiplied together is positive, right? A negative number and a positive number multiplied together is negative. And 2 positives is positive. Okay, so here, this is true when from -infinity to -2, or from 2 to infinity, but not between. Okay, so between -2 and 2, this is negative, so that's not true, and then this will be not defined. Okay, so what you want to do, then this one right here is from -infinity up to 5. Okay, so you want to take the intersection of those. So if you intersect those, you're going to get from -infinity to -2, union from 2 to 5. Okay, and that's going to be the domain for the sum of the two functions. Okay, for the second part, f minus g is just the square root of 5 minus x minus the square root of x squared minus 4, and the domain is still going to be the same thing. So that's just the same thing. So basically, we did all the work for D when we did when we worked it for A. And this one is just going to be the product of those two. And it's going to be the same. And then f over g, you just take that one and divide by the other one. And because here, in addition to forcing you wanting this to be positive, greater than or equal to 0, it can't be 0 either. So that knocks out 2, and that takes out 2 and -2 from your domain. So instead of, like in these previous ones, we had the what's this called? These brackets for the previous ones, you have to put a parentheses right there for the -2, and also for the 2. So the 2 and the -2 are removed from the domain because they would make the 0. They would make the denominator 0. Okay. Anybody have any questions about this problem before I move on? Okay, so let's go ahead and on to the next exercise. And this previous one was adding, subtracting, multiply, and divide. And this one is composition of functions. Okay, so this is more natural to compose two functions rather than doing any of the basic arithmetic operations. The composition of two functions is much more natural when you're dealing with functions. And this notation, with this little circle there, I don't really like this that much, but it is what it is. But you can always just like change it to the other notation, which is this right here. F of g of x, that's composition. And what I like to do is start with the innermost part and do substitution. So we know that g of x is sine 2x, so we can replace this g of x with the sine 2x. Like that. And then what you do is you say, okay, well, f of x is this, right, is x over 1 plus x. But this is f of sine 2x. So this x has been replaced with this. That means that these x's, they're like, replace us too. Okay, so x got replaced with sine 2x. That means that this x get replaced with the sine 2x. And this x down here also gets replaced with a sine 2x. Okay, and that's the answer to the first one. Okay, they also want the domain. So for the domain, sine is defined everywhere, so it's not a problem. We just don't want the denominator to be 0. So you want to avoid that. So that means, and if you solve for sine x, you get -1. Now, it would be really nice if this were greater than 1 or less than -1, and in which case, that sine is always between -1 and 1, so it can't happen. But sine does equal -1 every once in a while. Okay, so let's say this is the graph of y equals sine x. That's going to go like this, right? And it'll be -1 here at 3 pi over 2. And any multiple of that, okay? Okay, so sine x equals -1 when x is equal to 3 pi over 2 plus 2 pi n. Okay, and so that would work. But here we're dealing with sine 2x. So what does the 2 do to this graph? The sine 2x do to this. This is again, it's going to to this point right here, -1. Okay, so here you have the graph y equals sine x, right? What's the graph of y equals sine 2x going to look like? What does the 2 do? I guess my question is confusing, but I'm trying to get you to think that this is what we did in the first part. This is going to shrink it by a factor of 2. So this point is going to move over to here. Okay, to 3 pi over 4. This point is going to move to here. So it's going to actually go like that. That point moves to here. It's actually going to go like that. Okay, so for the answer, you're going to put, okay, so it has this x not equal to, and you're going to say 3 pi over 4 plus pi n. And it already says let n represent an arbitrary integer. Okay, so that would be good for the first answer. Okay, let's go to the second one, which is g of f of x. So that's g of f of x. And so that is g of, okay, so this inside part is f of x, which is x over 1 plus x. So I put that there. And then, so basically this x right here got replaced with x over x plus 1 plus x. And so you do the same to that one. So you have sine of 2x over 1 plus x. Okay, so that's going to be the answer to that part. And the domain, here the domain, sine's not a problem. It's just this denominator here is a problem. So you can't have, x cannot be -1. So you just have to do interval notation that excludes -1, like that. Okay, great. Now this next one, f of x. So f is x over 1 plus x, right there. And then this x right here got replaced with all that. So each of these x's got to get replaced with that. So this upper x gets replaced with that. So this right here is this upper x getting replaced with that. And then you got to replace the lower one with that. So there you go. Now you just have to simplify that. And you can multiply the numerator and denominator by 1 plus x, which is a fancy form of 1, by the way. Okay, that's going to cancel with that, so you just have x in the numerator. And then the denominator, this is going to distribute, though. Okay, so this times this is 1 plus x, and then this times this is just x. So x over 1 plus 2x. Okay, now it's kind of tricky, because this is, so if you just look at this, you're saying, oh, all we need to do is exclude -1/2, because -1/2 will make this denominator 0, right? So it can't be that. But also right here, x cannot be -1 either. So you actually have to exclude that point and that point in the answer, okay? So for part C, the answer is going to be like this. For the domain. Okay, great. And that brings us to the very last one. G of x, which is g of sine 2x. And this x got replaced with that, so I mean to just replace this x with the sine 2x. Okay, and so that's going to end up being your answer. And here the domain is everything, because sine 2x can take on any value of x and still be defined. Okay, so let's see here. We need to, oh dear. Oh, that's just great. We got 5 minutes to do 3 problems. Okay, f of g of x. Okay, so that's f. Now f of g of h. Okay, so I'm going to go a little bit faster here because we have a little bit to cover. So the h of x gets replaced with this. Okay, now here, this x got replaced with this, right? So you're going to replace this x with that. That's the replacement, and then there's the 3 right there. Okay, and then finally, this x right here got replaced with all of this. So all of this goes in right there. Okay, and so that should be your answer right there. I'm just emphasizing that all this got stuck into here for that x there. Okay, number 9. This is actually going back the other way. Here we have a function u, and we want to find f and g so that that's equal to u of t. Okay, and you can refer to f as the outer function and g as the inner function. So for g, what you want to look for patterns that appear in here, and probably the best choice would be this tangent. So for g, there's this tangent here and that. So if we can let g of t equals tangent t, that's probably a good choice. That's a good choice. And then f of t, okay, let that be, take all these tangents and just replace them with t's. And that's going to be your f of t. Okay, so your answer is you're supposed to put this expression, comma, that one. Okay, and then number 10. Same thing as what we just did. They want this to be f of g of h of x. Okay, and they also say that they don't want any of those to be identity, because if one could be the identity, then it would just be pretty easy, because you could just make all of them the identity except for one of them, and then have the last one just be this right here. It's kind of cheating. Okay, so what you want to do is you want to start from the innermost one. Anybody want to guess what that should be? Little h of x.
Be an absolute of x.
Yeah, that's like the innermost. So you have x right here, you have x in the middle. You have only one x here, so that makes it a bit easier. And it's the first thing that hits x is absolute value. So that's the best choice. Okay, and then g of x, you could let that be 8 plus x. Okay, because if this x just replaces absolute value, that's g of h of x. And then f of x would just be the square root of x. Okay, so the outermost function is just taking the square root. Once you do all this stuff inside, you're going to take the square root. Okay, so that totally works. Oh, actually, we have one more problem after this. Whoa, I thought we only had 3, and I thought, whoa, we're making good time, but now there's one more. Oops. Okay, so let's do this one really quickly. So here we have graphs, and we're supposed to evaluate the expression. This is composition of expression of function. So here's f of g of 2. So first of all, you go to the value 2, and that's up here at 5. Okay, so g of 2 is 5. And then you go to 5, and that is 4. Okay, so the first one is going to be 4. For the second one, you go to 0 first, and f of 0 is 0, right? That's right there. And then g of 0 is 3, so that's going to be 3. Okay, because you go to 0, and that's 3 on the g. Okay, then here, that's f of g of 0. Okay, so that's, say g of 0, we already said that's 3. Okay, and then 3 gives you, and the f is 0. Okay, so f of g of 0 is actually 0. Okay, then we have this one right here, g of f of 6. Okay, so here we come over to 6, and we're up here, right? This is 6. So it's g of 6. Okay, then we come back over to 6 again, and g is not anywhere to be found. So this is undefined. Let's try yellow. That's probably not a good idea, but let's just try it anyways. Just so we can say, yeah, this is not a good idea. This is really bad. Okay, so g of negative 2, I come over to negative 2, and that is 1, right? And then g of 1 is 4. Okay, so that's going to be 4. And the last one, let's try orange. Okay, that's f of 4. So f of 4 is is 2. And then f of 2 is -2. Whoa, it's the first one that's negative. Okay, so that's how you do that.